In this question, it is given that let x, y, z are greater than 1 and the matrix A is given by this. Then you have to find the value of adjoint of A square. Before I do this question, I will say remember that determinant of adjoint A is equal to determinant of A to the power n minus 1, where n is the order of the matrix A. And second thing to be remembered is determinant of A to the power n is determinant A to the power n. And now this thing implies that this is equal to determinant of adjoint A square to the power 3 minus 1, because A square is a matrix of order 3 by 3. And this is equal to determinant of A square to the power 3 minus 1 and to the power 2. This 3 minus 1 has become 2. This 3 minus 1 has come because of formula, and A square is this. That is, I get determinant of A to the power 8. And now simply we have to find the value of determinant of A. Clearly that determinant of A will be equal to, in first row every element has base x. Therefore 1 can be written as log of x to the base x. It is log of y to the base x. It is log of z to the base x. Similarly, in second row, it is log of x to the base y to log y to the base y and log of z to the base y. And lastly, it is log of x to the base z, log of y to the base z, 3 log z to the base z. And we know the formula log of a to base b is equal to log a upon log b. This is equal to, and in every term using this formula, from the first row 1 upon log x can be taken common. From second row 1 upon log y can be taken common. From the third row 1 upon log z can be taken common. Hence I will be getting 1 upon log x, log y, log z into log x, log x, log x. After one denominator have been taken common, these will become log y to log y and log y, and third will become log z and 3 log z, and this is equal to 1 upon log x, log y, log z. And now take log x, log y, log z common from first column, second column, third column. I will be getting log x, log y, log z, and here I will be getting 1 1 1 1 2 1 1 1 3, and this is equal to, using C2 changes to C2 minus C1 and C3 also changes to C3 minus C1, will be getting 1 1 1 0 1 0 0 0 2, and clearly this is equal to 2. Hence the value of determinant A is 2. Therefore this will be equal to 2 to the power 8. Hence I can say second choice is correct.